Hi, today we're going to be talking about the factored form of quadratic equations. That factored form generally looks like this. We've got y is equal to a times x minus p, parentheses x minus q. And that a is the same that we have in standard form, y equals ax squared plus bx plus c. That a is the same, it's just factored out. So we have to determine whether the parabola will open up or will open down. If a is greater than 0, that is to say it is positive, then it opens up. If a is less than 0, which is to say it's negative, then it opens down. Next we want to find the zeros, or the x-intercepts. Let f of x equal 0 and solve the equation. So let's say we've got f of x. And remember that f of x is just another way of saying y that can be used interchangeably. So we set this equal to 0, which our equation then is a times x minus p times x minus q. And those p's and q's will be numbers, but we would take those two factors. X, we'd ignore the a because it's a constant. It'll be a number, so it'll never be equal to 0. So we'll have x minus p equal to 0, or x minus q equal to 0. And then we solve those equations for x. So here I would add p to both sides, and that gives me x equals p. Or here I'd add q to both sides on the other side, and that would give me x is equal to q. And so our two x-intercepts would then be p comma 0 or q comma 0, or and q equals 0. So those would be our two y-intercepts. I'm going to circle that D2 just to get in the habit of circling our answers. Then we'd mark those intercepts on the graph, and we'll see that when we get to an example. Find the y-intercept by changing from factored form to standard form by multiplying. And we'll do that again as an example, but just to remind you, that's going to come out when we multiply it to y equals ax squared plus bx plus c. And the y-intercept then would be the point 0, comma c, whatever that last number would be. And then 4, find the axis of symmetry and the vertex. So remember here that h is equal to the x-coordinate, h, where x equals negative b over 2a. And the k, which is our y-coordinate, would be equal to f of, and then we just substitute in negative b over 2a, or the number that we've found once we've evaluated it. We'd put that back into the equation in standard form, and whatever it comes out to be, that would be our coordinate. So then again, the vertex would be h, comma k, and the axis of symmetry, this would be our vertex. And our axis of symmetry would be x is equal to, and then again, whatever that number comes out to be, negative b over 2a. And that's the vertical line that goes through that point. As a point to remember that a parabola is a smooth curve. Do not draw straight lines. So you shouldn't see a V, you should see a U. All right, fill in the requested information for each function and then draw the graph. So on A, just as a reminder here, we've got y is equal to A times x minus p and x minus q. And A is the number that comes before that, those sets of parentheses. If there is no number, recall that A then equals 1. And 1, since A is 1, and since 1 is greater than 0, since 1 is positive, it opens up. Okay, and then the vertex. Once again, here we've got x equals negative b over 2a, and that's negative. Oh, hey, I'm not able to find that until we multiply this out and get the standard form, because then I don't know what b and a. I know what a is, but I don't know what b is until we multiply this out. So I'm going to take this and I'm going to make a box down here. And I'm going to put x minus 1 and x plus 3. And x times x is x squared. X times minus 1 is minus 1x. And 3 times x is 3x. And then 3 times negative 1 would be negative 3. So when I put these all together, I've got y is equal to x squared minus 1x plus 3x minus 3. And I want to combine the middle two that are like terms. So you get y is equal to x squared plus 2x minus 3. And now that it's in standard form, I can see that a is equal to 1, b is equal to 2, and c is equal to negative 3. Now I can go back and say, okay, negative value of b, and b is 2, so I'm going to put negative 2 over 2a, and a is 1. So this is negative 2 over 2, and negative 2 divided by 2 is negative 1. And so our vertex is the point negative 1. Now that's the x-coordinate. We need to find the y-coordinate still. For that, we're going to use this the standard form that we just found, and we're going to put in y equals negative 1 squared plus 2x, that's plus 2, and x is negative 1, minus 3. And as a result, we get negative 1 squared, which is 1. 2 times negative 1 is minus 2, and then we have minus 3. 1 minus 2 would be negative 1, and negative 1 minus 3 would be negative 4. And so I'm going to circle those two. The y-coordinate then is negative 4. So that is our vertex. I'm going to put a little box around that to mark that as an answer, which is the vertex. Then we ask, is it a maximum or a minimum point? Since it opens up, the vertex will be at the bottom of that, so it's the lowest point, and so we would say this is a minimum. And the axis of symmetry is just the x-coordinate, so I'd say x equals negative 1. I'm going to go in here and graph the points that we found. Negative 1, negative 4. is this point down here. And the axis of symmetry, if you can see, I'm making a dotted line along there. All right, then the zeros are the x-intercepts. So we go from our factored form, and our factored form is this one up here that has it factored. So we're going to say this happens when y equals 0. So I've got 0 is equal to x minus 1 times x plus 3. So here is we set these equal to 0, so I've got x minus 1 equals 0, or x plus 3 equals 0. And then I add 1 to both sides here. X then equals 1. Or here I subtract 3 from both sides, and x equals negative 3. And so our zeros, our x-intercepts, I'm going to put a box around this. And I'm going to put a box around this just so that we are drawing attention to our answers. Just makes it easier for you to recognize what your answers are, but also makes it easier for us as the teachers to see what you've done. So we take 1 as one of our x-intercepts, and remember that the y-coordinate's always 0. And then the other x-intercept is negative 3 in x. And again, the y-coordinate is 0. And so this are our x-intercepts. And let's go ahead and mark that on our graph. 1, 0 is right here. And negative 3, 0 is right here. And if you look at that, this is 2 units away from our axis of symmetry, and this is also 2 units away from our axis of symmetry. So that sort of helps you to know, hey, we've done this correctly. Just erase that because I don't want to leave it. I'm trying to be nice and neat. So y-intercept, this is where the standard form comes in handy. The y-intercept is simply the c value, which is negative 3. And so our y-intercept is 0, comma, negative 3. So we come back over to our graph. 0, comma, negative 3 is this point right here. And the nice thing is that because of the axis of symmetry, we can just go over, this is 1 unit to the axis of symmetry, and 1 more unit to the left gives us another point on our graph. Okay, and then let's see, our domain. Our domain is all real numbers, which we can write with this symbol, or we can write all real numbers. And then our range. And if we look at our graph now, we can see sort of what's happening. Remember that as you're doing this, it should be a curve, not straight lines. That really matters mostly down by the vertex. The other numbers, the other parts of sections of the graph might look a little bit flat, but even those curve slightly. And then we draw arrows on the end to show that this graph continues on upwards. And it has, as we pointed out already, a minimum. I forgot to put a box around my y-intercept. And then the range starts at y equal, remember that the domain is all x values, and the range is all the y values. And so it goes y is greater than, because it goes up, or equal to -4. And as a reminder, we can also write this in interval notation. That means the lowest point on here is -4, and it goes up in y all the way up to positive infinity, which we use a parenthesis to show that it can't actually reach infinity, because you can always go one more. Okay, so I'll see you in video 2 here in just a moment. Thanks for watching.